Question 1. Identify the types of lenses shown in figure 1. So lens A, that is a concave or diverging lens. Lens B, that is a convex or converging lens. Part B of question 1. A student used the apparatus shown in figure 2 to determine the focal length of a lens. She adjusted the position of the lens and screen to obtain a sharp image on the screen. She measured the image distance V, deduced the magnification M of the object, and recorded her results in table 1 below. The table 1 has row headings V in centimeters that go 20, 30, 40 up to 80, and M, which is the magnification, which has no units, and those values are stated as well. If we were to draw a graph of these values using a scale of 2 centimeters to represent 0.50 on the y-axis, what would it look like using the grid provided on page 7 for 8 marks? So the grid provided in the exam paper already comes with the title at the bottom, so all we need to do is to make sure we label our axes. So our horizontal axis, that will be the image distance V in centimeters. The vertical axis will be the magnification M, again that has no units. Then we need to pick a suitable scale. For the horizontal axis, 2 centimeters to represent 10 centimeters would be suitable, and on the vertical we were told to use 2 centimeters to represent 0.5. So that means that we'll number starting from 0, and then we skip 1, number 10, skip, then 20, skip 30, and so on and so forth until we reach all the way to 80. And then similarly on the vertical axis, we start at 0, skip 1 and 0.5, then 1.0, 1.5, 2.0, and so on and so forth, all the way up to 4.2. That's all we'll need. Then we'll plot our values. So when CXC grades, you get 1 point for every 2 marks that are plotted accurately. So here we have 7 points that need to be accurately plotted. So that will be 1, 2, 3, 4 marks. Then we need to draw our line of best fit. That will be the final and the 8th mark. Our line of best fit should go through as many of the points as possible. If 1 or 2 aren't on the line, that is fine. There are always experimental errors. Then part 2, we are to calculate the gradient G for 6 marks. So remember that gradient is rise over run, or y2 minus y1 over x2 minus x1. So whenever you find the gradient for the Physics CSEC, you get a mark for drawing your dotted triangle. Remember that the dotted triangle should not be points that are on your line of best fit that were plotted, but any other points on your line of best fit. So here we can pick these points that you see being outlined with our red dotted line. The lower left hand corner has coordinates of 30, 0.75, and the upper right hand corner has coordinates of 75, 3.25. So substituting into our equation for the gradient is going to be 3.25 minus 0.75 divided by 75 centimeters minus 30 centimeters. So that's going to be 2.5 divided by 45 centimeters, which will be 0.056 per centimeter to 2 significant figures. Part 3 says, given that G is equal to 1 over F, calculate the focal length of the lens F for 3 marks. So for 3 marks, first thing you should do is to rearrange that formula to make F the subject, because the focal length F is what we want to find. So rearranging G equals 1 over F, we would have that F is equals to 1 over G. The second mark is for simply substituting. So we'll have 1 divided by 0.056 per centimeter. And then finally, we'll get 18 centimeters rounded off to 2 significant figures. Part C of question 1 says, figure 4 shows a full-scale diagram of an object O, which has a height of 3 centimeters. The object is placed 8 centimeters in front of a diverging lens L. Part 1 of Part C. Given that the focal length of the lens is 5 centimeters, draw the ray diagram in figure 4 to find the image of the object for 4 marks. So Since we know that the focal length of the lens is 5 centimeters, then we can put our capital F at 5 centimeters from the optical center. Then we need to draw our rays. So the first and easiest ray that we can draw is the one that goes through the optical center, because that is going to be a straight line, because any ray that passes through the optical center is always undeviated. Then next, I'm going to draw a line that is parallel to the principal axis, and when it reaches the lens, it's going to refract away from the principal axis, and it refracts in such a way that it appears to come from the principal focus capital F. When I retrace those lines back to the principal focus, I should use dotted lines, because we use dotted lines for virtual light rays. And then finally, the actual image of the object, I have my vertical arrow to represent the object at that point. Then part 2 of part C says to record the image distance. From my scale drawing, I see that that is approximately 3 centimeters. Part 3 of part C says to state whether the image is real or virtual. Well, it's going to be a virtual image. How do we know? Well, it's because that light ray that we use with the dotted lines, that means it's a virtual image. Besides that, you could also know that it's going to be a virtual image because diverging lenses only produce virtual images. And that's it for question 1.